Okay, so here we are at a browser, just at google.ca, and the purpose of this part of the video is just to show you how you can use Python to randomize variables in a problem and also solve a problem. For those of you that are already familiar with Python, a lot of this you'll already know, but hopefully there's some useful pointers that will help you when you're making your problems. The first thing that I'll do is I'll say, for anyone who is a little bit new to Python, I've got a set of tutorials, and so if you just search for my name, my webpage appears here, and if you scroll to the bottom, there is a link to some Python tutorials. Before we go there, I'll just make a note that this website is hosted on the UBC people server, people.oak.ubc.ca. So apparently that's going to be taken down at some point in the summer. However, all of this content has been copied over to the same kind of URL. If you just add cmps dash before that, it'll take you to the exact same page. So the Google search right now probably won't have the CMPS part, but later in the summer that will be necessary. Anyways, we go to the Python link, and there's a whole bunch of tutorials separated by categories. So there's some basics, solving systems equations, plotting, writing functions, importing, exporting data, fitting data, and so on. So you can check that out if you think it would be useful. The easiest way to get started coding Python is just to make use of a system that UBC has. So if you just search for UBC Python, the one you want is here. And so if you click on that, it'll ask you to log in, and it's just your CWL. And so I'll log in, and I have to authenticate that with my phone. Okay, and here you go. You'll be presented with something like this without, my files showing up. And to start a new set of code, you just go to new Python 3, and this is a Jupyter notebook. And you're presented with a cell, and you can just start putting stuff into the cell. 3 plus 6. To execute this, you could either hit run, or you could hit shift enter. And then you could do some obvious things like 3 times 6 is 18. One thing that will not work maybe quite as you would expect is powers. So often to raise something to a power, then syntax is 3 and then this caret symbol and then the power. So this would be 3 squared, and it doesn't return 9. I forget exactly what this represents. It might be the remainder of 3 divided by 2, but I'm not 100% sure. Anyways, in Python, powers are done by using 2 consecutive multiplication signs, and so this will return 9. So 3 raised to 3 is 27. Okay, and then if you wanted to use a trig function, you might try sine of 3, and you're going to get an error. And the error is that the sign name is not defined. So in Python, what we have to do is we have to make use of modules. And so to use them, we have to import them. The most useful module is probably NumPy. And it's common to import NumPy as NP. So shift enter, and we've imported that. Now, if we wanted to use sine or another trig function, we would just lead it with np dot and then the trig function, and this will work. So if we wanted to take the sine of pi by 2, for example, the NumPy module also has a pi function, so it's np.pi, and then we can divide by 2 and we should get 1. So when we did our import statement, had we not added on the as np, we would have had to type numpy dot sign bracket numpy dot pi divided by 2 close bracket. Okay, so that's good. Let me just show you how you could write a for loop. So before, actually before we do that, let me show you how you'd make a list. And so let's say X list. You're just going to use square brackets and you're going to separate the elements of that list with commas. And so we'll go Shift Enter. And then if I wanted to select an element of the list, let's say I take 3, what we get is minus 45, and you'll notice that that's the 4th element in the list. That's because in Python, the first index is always a 0. So X list of bracket 0 is the first element, 1. Okay, so if we wanted to write a for loop, for example, we could say for I in range of, let's say 4, and then we'll have a colon. And when we hit enter to start a new line, it'll automatically be indented. So anything that's indented will be inside of this for loop. And so we might just say print I, and that's it. We don't have to have an end for statement or anything like that. If I wanted to add lines below this, I would just add them without indenting, and that would signify the end of the for loop. So if we go Shift Enter, we just get 0, 1, 2, 3. And so that's 4 iterations, but I starts from 0 and ends at 3. So what we could do is, let's do like an x squared list. So I want to square all the elements in this list. There are better ways of doing this, but let me just show you how you could do it using the for loop. So we'll first define an empty list, so it has no elements in it. And then we'll go for I in. And so instead of saying in range and then giving it an integer, we could say for I in the X list that we already defined. That will take I and iterate it over the elements that are inside of X list. So in the first iteration, I will be 1. In the second iteration, it will be 3, and then it will be pi, then minus 45, and then in the last iteration, it will be 3. So we need our colon, and then we could say x squared list is equal to x squared list plus, and then we could do I squared. And for this to work, that would have to be in square brackets to append that element into the x squared list. And then I'll go and enter, and I want to end the for loop. So I'll get rid of the indentation and then just ask for the square list to be shown to us. Okay, and then we'll go Shift Enter. And 1 squared is 1, 3 squared is 9, and so on. Okay, and so that worked well. There's kind of a neat little notation that Python has. So instead of having to type square list is equal to square list plus something, we could just do plus equals, and that should result in the same thing, and there it is. Okay, good. So in our Prairie Learn problems, we're going to want to randomize variables, and we're going to make use of another module to help us do that. And that module, that module is import, and it's random is the module we'll want. And so Shift Enter to import that. And so the module random has a function called choice, and so we'll go random.choice. And what we want to do is we want to pass this a list. 1, 2, 6, 8, minus 90, You don't need spaces after the commas, but it's usually what I do. And so if we run this, we get one of those elements. That time we got 6. Now we get 1, 8, 6, 8, 2, minus 90. Okay. We could have, because we already had a list made, instead of rewriting the whole list, we could have just used our X list. And now we'll get, so that time we got pi minus 45 and so on. Okay, so what this random.choice should do is it should choose from these, how many different elements did we have? 5 different elements. And so the probability of each element being chosen should be about 20% of the time. Okay. So let's just, for the sake of it, let's just write this in a for loop. So let's say for I in range of, say, is that 10,000? I think that's 10,000. Then what we could do is, let's start with, oh, sorry. I want to just enter, not shift enter. Let's start with an empty list. Let's just say a list or something like that. Okay, enter. And then we want a list to be equal to a list plus, and then we'll take our random choice, put it inside some square brackets, and at the end of all of this, we'll just say show us what's in a list. And that should work, I think. Let's try it, shift enter. There we go. And so there should be 10,000 different entries here. And what we should find is that about 20% of them, or 2,000, should be for each of these elements. And so we could try, I think, to verify that that works. And so let's do this. Let's say count is equal to 0. And then we'll go for I in, let's say a list, colon. And then we could write an if statement. So we say if I is equal to, let's say the minus 45. Let's count how many times we get minus 45. So we'll end our if statement, our initial if statement, with another colon, and we get another indentation. And so if that's true, then we're going to increment count by 1. And if it's not true, we'll do nothing. So we end our if statement by just getting rid of this indentation. And we end our for loop by getting rid of that indentation. And then so we could say take count, divide it by 10,000. And that should be, if I've done this right, a number close to 20%, or 0.2. And so let's run it. Yeah, there we go, 0.2081. So pretty close to 20%. All right, so that's kind of a little crash course in a couple of Python features. So what I want to do is I want to shift gears here and try to solve that problem that we had previously thought about. So I'm going to make a new notebook, and I'm just going to go back to this window, or this tab, and say new Python. And I'm just going to reset the kernel, restart. And so nothing from this previous notebook that we've been working on should be in memory. And so to start, I'm going to re-import the modules that we're going to make use of. And so it's numpy and random. Now, if you remember, our problem was a solenoid that had a certain number of turns per unit length, and it had a certain value of, so actually, what did it have? I think I've got it here. Here, I can show it to you. So it had a certain number of turns per unit length, and there was an electron inside of it, and it was moving in a circle of a certain radius, and it was moving with a certain speed. And so what I want to randomize is the number of turns per unit length, the radius, and the speed of the electron. Okay, so we'll first import our modules. And then to make a comment in Python, you could just be, it's a hashtag, and then everything after that won't be code that's executed. And so let's just make some notes. Randomize the variables. Okay, so the number of turns per unit length, let's say n is equal to random.choice. In the problem, the value was 25 turns per centimeter. And so what we can do is we can say, no, maybe we'll accept 10, 15, 20, 25, 30, 35. Okay. Oops, sorry. I wanted to do just an enter, not a shift enter. Okay, and so that's the number of turns per unit length, and maybe I'll just remind myself that this is in units of inverse centimeters. Another thing we wanted to do was to randomize the radius of the circle, and so we could say r is equal to random.choice. And so let me show you a nice way of doing this, constructing this list that we're going to need. Instead of typing out each of the individual values that I might want to use, I'm going to make use of something called linspace. And so this is from the NumPy module. And it's just going to be a set of numbers equally spaced between some range. And so the radius given in the problem was 2 centimeters. And so maybe I'm going to allow my radius to be between 1 and 3 centimeters. And then the other thing I have to tell it is how many elements do I want in this list. And so maybe I want this to go 1, 1.1, 1.2, all the way up to 3. So 3 minus 1 is 2, and if I'm going to have them spaced by 0.1, I'll need 20 elements, but I have to add 1, right? If I put in 20 elements, then, I don't get the nice increments. It's 21 to account for the fact that I'm going to start at 1 and end at 3. So there we go. So instead of typing all of those out in my random choice, I'll just put in this np.linspace. Notice it's already inside square brackets, and so I don't have to add square brackets there. Okay, and so I can get rid of this line. And then the other thing was the velocity. And so in the problem, the velocity was 2 times 10 to the 5 meters per second. And so here's an example where, you have to think a little bit about what your random variables can be. We don't want it to be a velocity that's close to the speed of light. So we want whatever we choose to be much less than, something like 3 times 10 to the 8. Maybe I'll use the same range of values, the 21 values for 1 to 3, stepping by 0.1. And then what I often like to do, actually, let's remind myself, this is in centimeters, and this is going to be in meters per second. I often like to separate the power and have that be also its own random choice. So it was 10 to the 5 in the problem, and so maybe we'd be willing to accept powers of 4, 5, and 6. Okay, and so those are our random variables. And then if we go Shift Enter, we could look at the values that we got selected, and so it selected 30 turns per centimeter, radius of 2.8 centimeters, a speed of 1.8 times 10 to the 5 meters per second. So the first thing I'll do is I'll just construct my velocity. So my velocity is going to be the coefficient, which was 1.8, and then it's going to be times 10 to the power of 5, and this is going to be in meters per second. Let me also, while we're at it, fix the units of some of the other parameters. N was originally in inverse centimeters, and so if we have 100 centimeters per meter, I need to multiply that by 100 to get this in units of inverse meters. And, whoops, sorry, I always mix up shift, enter, and enter. The radius we want to be in meters, and so that we're going to divide by 100 to get from centimeters to meters. And then what we could do is we could look at the value of the turns per unit length, the radius, and the velocity, all now in good units. So we have, let's see, oh, you know what I did? Okay, I screwed this up. So let's restart all of this. Okay, so I executed this line twice, so I multiplied n by 100 2 times. So let's fix that. There we go. So now n is 3,000 turns per meter. The radius is 0.019 meters, and the velocity is 2.1 times 10 to the 5 meters per second. Okay, and what we can do now is we could just calculate the current that we were supposed to calculate. We previously solved that the current was going to be equal to, well, the mass of the electron, which we haven't entered. So let's say the mass is going to be 9.11 times 10 to the minus 31 kilograms. We're also going to need the charge of the electron, and so we'll say Q is equal to 1.6 times 10 to the minus 19 coulombs. And we're going to need the mu naught coefficient, the permeability of free space. And so I know that that's 4 times 10 to the minus 4 times pi. And so we need numpy for that. And I'm not going to bother writing down the units. I'd have to work them out. Okay. So now what we've got are our randomly selected variables and our fixed values. And so we should, I think, be able to calculate the current now. We previously worked out that it was the mass times the velocity divided by mu naught times the number of turns per unit length times the charge times the radius. And I think we have all of those values. And because we're all in good standard units, the result should come out in amps. And if we go shift enter, here, let me just put an I down here so we can see the value. And so this is saying that it should be 0.0167 amps or 16.7 milliamps. And so that's the solution. And so these are the kinds of things that you would do in the section of the markdown file that you're going to write to actually solve the problem. So there'll be some additional syntax that we'll have to get right in order to get this working in Prairie Learn problem. But this is the basic introduction to using Python to randomize variables and then solve the problem. All right. Thank you very much.